Is my voice audible? Okay, let's start solving this question. Welcome to Late Night Dreams. Given an array of integer and d in one step, you can jump from index I to some index x. That would be in a range d. You can only jump from I to j if and only if that I value went from I to j. If I find some greater element than array of I, can we do it in a brute force DP way? I'm assuming that we can solve it using brute force technique. So okay, let me try that brute force thing. Array, yeah. Okay, our initial goal is to take array size. Now use simple recursive approach. Okay, we need to get a maximum number of indexes that I can visit, right? Maximum number of indexes that I can visit. Maximum number of unique indexes that I can visit. Do I need to maintain a state? Do I really need to maintain state at every index? Then it would be a problem. So a normal DP would backlash here. So thinking of some, so 75% acceptance rate, nice. Let's take some observations. Maybe we are missing some clues inside the question. Initially, I will write constraints like when up to 183, D up to 183, D star N gets AC. Next. So instead of what I can do, what I can do is I can jump from J only A of I greater than A of J. So we can only jump from higher tower to lower tower, and A of I must be greater than A of J for all, yeah, A of K, J, assume it like all values between I and J. So I and K, must be smaller than array of I, and array of I must like I uh, must be larger in every value than every value. So it's jump. So basically I can do is like thinking of a greedy solution as greedy. We we can assume the current window is from I to I plus 2 star B. If one assume from and then we move from I plus 1 again, the range will be problem. The range will be problem. Yeah. What? No, 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 no. We can start jumping from larger element. What if we can jump to smaller element? Can we just simulate this? Can jump to this value. Next we can jump to at every index. I'm thinking of choosing some other element. Hmm. But these are already visited. And if I visit, what if I visit in a monotonic way? The visiting of values should be in monotonic way. We can't visit a higher value after a lower value. So the answer of some element would be same, same. There is no use of using visited array again. What if it has some duplicates? We visit values in decreasing order. So I think no need of order. Okay, we can't visit the same value again. We can only jump to strictly smaller values. So this is a big clue here. So what I'm assuming that we iterate from, okay, let me get to the point. We create okay, about tabulation, about memorization we will think later, but for now we will get the answer with brute force, whatever. Uh, Max of r comma f of a comma I comma d. In this function f int about chart, right? About chart. Let me check. Do I get any views? No views. Okay. Hmm. We can continue. In function f vector int array index I and int the distance d. So int l equals to min of 0 comma I minus b and r equals to min of a dot size minus 1 comma I plus b. These are the ranges. So we can go back or we can comprehend int c equals to 0. We visited this now, so we can make it 1 for int I equals to for int like j equals to I, j greater than or equals to l, j minus minus. The value must be like if I encounter a value that is greater than or equals to a of y, then immediately I will break it. Else we can go there. A comma j comma d. I think that's it, isn't it? Into j equals to okay, we can't go to the same place again. So we keep I minus 1 equals to I plus 1 and j less than or equals to r j plus plus. If I found any j greater than or equals to array of I, simply break else c plus equals to f of a comma j comma d. That's it. This work well. Uh, min of array of size minus I plus 2. That size with what? Well, it's giving error. Okay. Yes, semicolon too many type errors. I need to change my keyboard. It is most okay. Yes, to return R. Hmm, what was the error? L and R. The declaration was right. Wait, let me check. I for zero itself, I'm getting an error. Of field greater than array of field of field and what and what could be the error? Here, I think I need to print. There is a termination, right? How could be there? How could there would be a loop? I also mentioned equals to condition. What you guys think? I think I can find it now. There is some infinite loop going on. Yeah, zero. Is it out of bounds thing or what? Without size minus one. Yeah. Okay, maximum of. Sorry. Hmm. Just think about thought dot. Okay. Okay, why not seven? How could be seven? How can I get seven? A plus D plus two. Yeah, I can't go there. At what index I'm getting? Let me check. At index two? How can I? Okay, here one, two. From here to here, from two to two to eight. F of a comma I comma. Let me check individual values. Hmm. 3731. Okay. 42. Okay. It can't go to seven indexes. How can it go to seven indexes? 14 from one. One by one. Two, one, zero. Again one. How can I go from one to zero? Okay, from two I visited one. Okay. Again I am visiting same one from zero. How many things that I'm visiting really matters here? What I must do is I need to greedily walk to the farthest node that I can visit and only passing there. Will that even work? If there is a thousand node, which is the greatest one, and I can come back to here again to collect all my yeah all my things. So what is the farthest possible node? Farthest and greatest. Yeah, like that. If I have keep values, like there are values lower than this, and uh, hmm, minus one, and comma current value would be minus one. There are no negative values of 10. Okay, T equals to the current value equals to yeah. So similarly, okay, we will increment counter here. Okay. C plus equals to f of a comma 2j comma d. Similarly, if minus one and c equals to minus one, if t not equals to minus one, then only we will need to proceed it, right? Similarly here, okay, simply copy this. Yeah, for here too. I think it still have some edge cases, but let me try. Can it really? Five. Nice. Mhm. How could the five? 2 0 compared to 0. I think no plus here. Oh man. Instead of adding them, I need to extract the maximum one. Yeah. Okay, c equals to 0. C equals to max of C comma 1 plus, okay, initial C would be 1. C comma 1 plus f of, yeah, need to do the same here. We can't add everything, right? Yeah, it would be accepted. Hmm, nice problem. Just memorizing it would be much more helpful. So, vector in dp of n comma minus 1. I'm using only dp. Uh, How 100 dp was enough? Only one state, right? Yeah, here the main thing is about how can you eliminate that visited array index? That would be a really difficult thing. Actually, while maintaining the states, we need to maintain the visited index too. P of I not equals to minus 1 of dp of I. Yeah, some need to comment out. Okay, I commented out everything. Let me submit this. Yeah, it's got accepted. Bit only 48%? Man, this is- where did I get the answer? Yeah, through this agreed solution. Not, yeah, this point gave me the clue. Yeah, this is another point which supports the above point. Yeah, by this we solve this to the LeetCode POTD. So far, no use, right? Who watch? Someone must watch. Let me check the string health. Yeah, it's good. Should I end here or should I do some more problems? I should check some hard ones. This is the some beginners kind of problem. Not a beginners kind of, but yeah, with small mistakes I solved it. Today's contest problem. Some interesting problem. Can we go for thoughts? Yeah, hard one are the best one. Pick random. Man, matrix. Okay. Matrix problems are one hell of a problems. We can't optimize that n square. If there is an optimization, I don't need it. Create smallest lexicographical order. These are the some reverse backtracking kind of problems. Yeah, and is one in nine. I don't want to solve this to nth. How beautiful such strings problems. Not don't want to solve this one too. 24, 27, 25, 28. Okay, let me read this one. A given string s and pass into the k. Number of those and number of function. Okay. Mm-hmm. Okay. What the telling is you need to count the number of substrings where the vowel count and consonant count must be equal and their multiplication modulus k must be equal to 0. Two conditions. How can we do two? How can k equals to 1000 will satisfy like will optimization will cause optimization? Pick this letter 294. Ah, oh, number theory maths. I don't like maths. Job difficulty 300 and 1000 backtracking kind of. Okay, job scheduling. Skipping, man, I'm skipping too many problems. So now, zero views. Hmm. Okay, I'm ending the stream.